That's right. I can yell. Okay. All right. Welcome back. This is our last session here of this great workshop. So we're going to be talking about networks to wrap everything up. So we're going from sensor to network here. And our first speaker will be our host, Stephen Quiring, talking about a little pet project he's been working on the last month or so, maybe something like that.
All right, good afternoon. I am excited to share sort of where we're at and some updates. It feels like I kind of talk about things related to this from time to time, and mostly what I'm sharing is not work that I personally have done, but acknowledging all of the graduate students and postdocs and collaborators that are involved in this. So this is the list of co-authors up there, including some people that you may have seen already present here, as well as the others that have presented on this and worked on this in years past. So today I want to focus on a project that is funded through the NEFA part of USDA that is a high resolution soil moisture and evapotranspiration at field scale. And so this is designed to be an operational, near real time, field scale soil moisture and evapotranspiration data set. It's a very ambitious goal. And as you may have learned over the past few days, there are many challenges involved in this because we are planning to assimilate and incorporate data from many different networks, and to also assimilate and incorporate information from models and from remote sensing. And we're also wanting to push this down to what we call field scale, which when I'm saying that word, I'm thinking 400 meters, so kind of a quarter section. And that's, again, at the edges of what, well, first of all, it creates a large data volume. So we've been running and generating 4-kilometer maps in the United States for a number of years. And that those file sizes sometimes cause us a little bit of a headache. But then if you want to go down to something like 400 meters, even just serving out and managing and thinking about how do we store the data, how do in our research group we use these data sets or do the training that we need. And so this is where it intersects with cloud computing and high performance computing and storage requirements. And do we want to do this locally? Do we want to do this in the cloud? So this project was originally a collaboration between myself and Vahid Ramini at Kansas State University. Earlier this year, Vahid decided he was going to leave academics. And so the part that's in black here is the evapotranspiration. So stuff that's in green, I would say that we've been working on and that we've made a little progress on, that I can kind of at least talk about where things are at. The things that are in black are the things that are, so we had divided this. Vahid was going to lead the evapotranspiration part. I was going to lead the soil moisture part. We were going to put it together. And so it's good for Ileana in that it gives her some job certainty over the next couple of years, since now we will be folding in the evapotranspiration part here at Ohio State. But we haven't really scratched the surface on that yet. So I'm not going to talk about that too much today. I will hopefully next year at the Soil Moisture Workshop be able to give you some updates on here's some of our ET products, here's some of our soil moisture products, and we're hoping to use and constrain errors in one product with the other product. So look at this in an integrated way as opposed to artificially sort of disaggregating these kinds of things. The goal of this is that we provide information that is relevant for a wide variety of users and stakeholders, for modeling, for operational decision making, for monitoring drought conditions, and for all kinds of different uses in both research and in the private sector. So obviously there's great potential value for this if we can do it well. Now, where are we currently? So this is a slide that I've showed at many past workshops. And this kind of outlines our automated process, our data pipeline, showing here for one example network to set up the next talk with SCAN, how we might pull in data in an operational way, how we would then automatically quality control it. So regardless of which network it is, regardless of what kind of quality control already goes on, we want to have our own standardized process for doing this. And then some of the things like decisions we made in the past about how we standardize things, or how long a period of record do we need to include, kind of like with Tyson's talk, which was a very nice synthesis of work that's taken place in his group over a prolonged period of time, where each decision, each sort of process in the step, there's a paper that where you validate the methods and test things, and then you learn incrementally. So we may not be fast, but we try and be thorough in documenting how and why we're making the decisions that we are. And so this obviously also leads to some of the opportunities that have come up through conversations at this workshop. So in the last session, thinking about quality control, this is why I would really like to benchmark automated quality control measures using an expert assessment of flagging, and to have, because there's lots of different automated quality control code that we could compare directly and see, is it the International Soil Moisture Network approach? Is it the approaches that are used by some of the mesonets? Is it what we're using? How do those different things compare in their flagging rates and their flexibility and detection rates of these issues? And so maybe as a community, I always like to think of this workshop and generate ideas. And there's been a lot of cool things. So like seeing the now multi-state test beds, that's so awesome. Like being an academic, you often think about academic, kind of your academic children and grandchildren, and how these ideas pass along. And so as one gets older, you get more sentimental about those kinds of things. And so seeing some of the things that happened and how those ideas then can spread and be improved on is exciting to me. So that also leads into the fact that for testing these methodologies, especially at field scale, what is it that we need? Well, we actually need test beds. We need places that are heavily instrumented, that have a large number of sensors in a relatively small area, because otherwise we don't know how good, I mean, we can arbitrarily use machine learning or deep learning to produce a data set at any resolution you want. 10 meters, sure, why not? But how good is that? That's something that we need to demonstrate through these past field campaigns that have been done. So leveraging all of the experimental SMAPBEX kinds of campaigns where there's been historical data collection and test beds, and the dense sampling that is done in some watersheds and in diverse ecosystems. So using data from places like Coweta, or using the data that Andres showed that's being collected in the Kanza Prairie. I mean, that's what we need for this project to be successful. It will rely on, as all of my work has done, the community to share data and ideas. And I love the fact that there is a GitHub repository of code. And so that's something that Ileana and I are absolutely on board with. And that as a community, again, sharing code and best practices for how we do these things if we want to be really successful and not reinvent the wheel all the time. And so whether it's separate GitHub repositories for the stuff we're doing and you're doing and everyone else, or we have some kind of centralized place where we can point to this and build on it and say, okay, well, your QC routine does this, we're doing it this way. Let's swap this part out and see how it works. That's also something that this community of practice could implement. So I always like showing this map, and this is one that Todd showed in his presentation. Ileana gets the credit for drafting this. It is always a work in progress. There are always places. So this is, it's always out of date. So there were some questions as we produce this, like what about this station? What about, why isn't this network shown? And so just if we were to create a version of this every day, you would see station blink on and off based on telemetry or sensor failure, or like, oh, someone signed a, a data sharing agreement, or signed it, or no longer is sharing data or whatever. So don't obsess too much about this. But if there are places where there are stations, and this has been my decade-long pursuit, right, is to add points to the map. And as has been done at many of these workshops, I find out about new networks that exist, or people that are interested in having their data included, or things that are on our map that are out of date. You're not going to hurt my feelings. Like we're running our 20 some scrapers, and they break from time to time. And so we have a much longer list of networks that we want to include than are included. And our goal, of course, is to, for every in situ station where there are sensors in the ground and people willing to share data, that we include it, but also that we quality control it and flag it. And maybe it's used in different ways for different purposes to get at this kind of one-stop thing. So always an ask, look at my map, critique it, tell us what we're missing, help us find data. And as a community, I will use my time up here just to say that I hope that where we get to is a place where these data can be freely shared for at least research purposes. And there is a lot of sharing that takes place already, but there are also some financial restrictions on networks that prevent data from being used. And so if someone's really interested in soil moisture in North Dakota, well, the North Dakota network, told us, hey, we're going to block your IP, don't take our data. So that's fine. It's their data. They paid for the collection maintenance of it. But it means if you're interested in drought conditions in North Dakota, you can't use any of the national maps that are created. And so if there's a way for us to pool resources, pool data, share things more efficiently as a community, I think that puts us in better place. So one thing that's relatively new, and we need some people to exercise these data, and this is work that Zach did as he finished up his PhD and as he started his postdoc, is going and generating this 2000 to 2021 daily retrospective gridded soil moisture. So we have surfaces of 5 centimeter, 20 centimeter, 50 centimeter interpolated soil moisture. So note that the data in 2000, there's not a lot of stations being done, and we still have reported a soil moisture percentile at every 4-kilometer grid cell in the United States. So we know that that's not like going to be the world's most accurate product, but it's now available in a lovely net CDF format. And Anna created this cool animation for me. And so this is the 5 centimeter data. So it's going to be pretty variable. You can see when there's precipitation that occurs. This is for 2012. And so with the data now in net CDF format, it allows you to kind of visualize and then also to utilize these data to compare and contrast them to other data sets that exist, and to help us, again, validate and improve these data sets. But keep in mind that a lot of this may not be very good, because there's some states where there's no soil moisture sensors. So you're in Ohio, so the interpolation in Ohio is a lot of interpolation and not a lot of data, unfortunately. So if you want that data set, talk to Ileana. We have a OneDrive folder and instructions on how to use it. Take it, critique it, send us feedback, and we want to continue to improve that. So the in situ data product, that's one of the products that we're producing that's up here. We also have the NLDAS rescaled, so we calculate it in percentiles and report that. the SMAP data, and then a blend of the data. And we can and should include additional data sets. So one of the things that came out of this workshop is getting access to the sport list data set so that we can add that, which is at a nice resolution. They have a nice long archive, and that is something I'm super excited about working on, and also adding in some additional remote sensing products. One of my previous PhD students did some work on how we actually do the blending for this. So I won't talk about that, but there's a paper that was published in 2021 in Journal of Hydrometeorology that compares all of the different methods of how you can do this with triple co-location or with simpler approaches, blending lots of different independent data sets. And so that's another sort of thing that we tested and validated and that we'll be improving on with this project. Finally, what we'll show at the AGU, so I'll just highlight it as kind of an advertisement, is to say that we want to demonstrate and compare the value of different approaches for downscaling these data to field scale. So Ileana highlighted a little bit of this work, but using machine learning and deep learning and lots of ancillary data sets to, and then showing the holdout validation. So at locations where we have a high density of sites. All right, so I told Trent, don't let me talk for more than 15 minutes. So I'm almost there. All right, so beyond this, where we will get to is serving out these data in multiple formats. This has been one of the weaknesses, honestly, of nationalsoilmoisture.com with the data format that we're using right now that has not been super user friendly for most people. So if you're using like Python, it doesn't really, the data format's good for ArcGIS, but that's only really a subset of people that want to use that. So we're improving this and also wanting to serve out these data in smarter ways, given the volume, so that it can be integrated more readily in other products. And so APIs are really the way to most efficiently do this, so that you don't have to download and store all of our data, that you can pull from it when you want to. And that's one of the goals of the FACT project. And then developing a robust code base that we can share and build on as a community. And so there are some really cool visualizations that I've seen this week and at past meetings, and great ideas for how to efficiently slice and dice data sets. And so our goal is to be more transparent as a research group by sharing what we're doing, so that you can say, oh, I like these parts, but I would replace this method. So maybe you don't like soil moisture percentiles, but you can put in FOG. And so you can, use the same code, but replace the part or improve on the part, and that we publicize this and say, please use it, please upload your code. And then as a community, then we move forward more quickly. So like to acknowledge past members of the research group and other contributors, and of course the funding for this project. Please do reach out if you have questions, if you want access to the data, the gridded data sets that we've created. So what I always say is that while we collect all of the in situ soil moisture data, we are not a repository for that. We don't collect the data, we don't own the data, we don't serve the data out to anyone else. We just point people back to all of the folks that are doing the hard work of putting the sensors in the ground and paying for the upkeep and maintenance of it, and give them credit where credit is due. So with that, I'll conclude and take any comments or questions that you might have. Yeah.
Steven, can you hear me?
Tilden, I can. Just hold on a second. We're gonna take the question in the room, then I'll come right back to you.
Gotcha.
I asked because they're not currently sharing data with the text message.
Yeah, so the question from the room was about the how we are acquiring data from the West Texas Mesonet and kind of the data sharing. So it, each network since 2011, I have had multiple conversations with every network. Sometimes when staff changes or funding changes, then the data sharing policy changes. So the networks that we're currently working with are those that have some kind of, have given me approval at some point in the last decade to do this. And we keep using their data through the mechanism. So sometimes it's a private FTP link, sometimes it's an API, sometimes it's just like, we have a scraper and it just takes data off their page because that's easier for them. So each case is very individual. I have not recently talked to anyone from the West Texas Mesonet, so maybe I'll need to ask for forgiveness at some point now that this is broadcast out to 27 people over the internet. So I don't know, but I am happy to pass along the conversations and contacts that we've had and the mechanisms that we are using. And yeah, I mean, there are some networks that I would love to be including on here that I currently have been told no thanks. And so that is a little disappointing because I want to fill in the map as much as possible, but I'm also not owning that data. So I'm just going with the flow. Yeah.
But then if those coordinates maps you've created tested against any other
Great question. So we have done all of our validations not against other products like Smurge. We have done them using, in our case, we consider the in situ sensors as our ground truth. And so our procedure of evaluation is a jackknife cross validation where we upscale the stations in each 4-kilometer grid cell and then compare the percentiles at the station to the interpolated percentiles. So holding those stations out, estimating the value, calculating the error that way. We have the data where we could actually do that same process, generate errors, differences for other products like Smurge. We have not done that, but it would be interesting to do. Yeah. And there was a question online.
Oh, okay, Stephen. So the question was, I presume you're using some sort of a daily mass balance approach overall with some constraints, using like daily precip gridded data and maybe a daily ET data or product or something like that.
So good question. The method that we have currently operational on nationalsoilmoisture.com does not use any kind of water balance approach or constraining things. For the USDA project, we will do that where we'll have soil moisture and ET. We use precipitation, so the PRISM daily precipitation and a antecedent precipitation index calculated from that is one of the inputs to our approach, but it is not a water balance kind of approach. It is a simply geostatistical right now for using the in situ measurements and then ancillary variables to estimate the value at unsampled locations. In the USDA project, we'll approach it a little differently.
So does it conserve the water, or is it a mass conservation with regard to water? I mean, so, sort of, you can't generate more water than what goes into it or what leaves. So are you constraining, using that as one of your constraints as well or not?
Not with what exists on nationalsoilmoisture.com today. There's no constraint on it for physical mass, conservation of mass, no,
Okay.
but we will at some point.
So Steve, this is Bruce. Have you thought about using, or is it even a direction you're going to go in is just try to look at the response functions of these soil moisture measurements as a function of soil type and vegetation, so that you got such disparate sensors across these different networks. Would it be useful to think about trying to figure out what those forcing functions look like between, which is precipitation was as a function of vegetation and soil type for these different networks, to maybe do a homogenization for these?
Yeah, I mean, I know what you're asking, Bruce. We, I think, are taking, so we're interested in thinking about and scoring performance in different ecosystems and different soil types, but we haven't done anything to look at the response functions uniquely in each of those. That's not something at this spatial scale, because we're at 4 kilometers. So we're aggregating tons of different soil types and vegetation within a 4 kilometer pixel. So even if we looked at that, it's not like using a station. So if we use CRN data where we know here's the soil profile, here's the vegetation at the site, it's less clear to me what that means if we have things aggregated over an area, because we're just trying to get the most accurate estimate in that area, which may not represent all of those specific soil type vegetation combinations. So it's a bit different approach than what you guys did with the CRN data. I think we're,
Yeah, maybe one more, but we had,
Okay.
yeah, trying to.
Just real quick, it's daily data that you're producing, or is it more frequent?
these are daily maps. So lots of the measurements come in at much higher frequencies, but we're producing a map that's meant to be a 7 a.m. local map of soil moisture. So we're purposely not looking at within day variations.
That's funny, because you're at a smaller scale than the basis that we deal with, but we need 6 hours.
Yeah, I know. Operational is like,
Thank you very much.
Yes, Devin, can you hear me?
yeah, sorry, Yulong, we're out of time for my questions. Send me an email.
Yeah, I just a quick question. One is the question is Trent first wanted to edit soil temperature, but eventually is not finished. Do you have any plan to continue do that, or just you drop off?
Soil temperature. Sure. If someone wants to fund us to add in soil temperature, we'd love to do that.
Okay.
Okay,
Thank you.
thanks. Let's move on to our, yeah, and if folks have other questions or anything for Stephen, they can type them in, and Michael, or as Stephen invited to email. Our next speaker is Kent Sutcliffe, who's going to be talking about the SCAN network. So go ahead.
Great, thank you. Thanks for the opportunity to talk this afternoon. I really appreciate it. Since it's getting late and I'm a dad, I was hoping I could start with a quick joke. My kids aren't here, but it may be funny anyway. Just a quick question. Why does the Norwegian Navy have barcodes on their ships? So when they return to port, they can Scandinavian. Anyway, this will be a light presentation from a science standpoint. My name is Kent Sutcliffe. I am the newly minted West Region SCAN coordinator. SCAN is the Soil Climate Analysis Network, as most of you know by now. And joining me today is Dave Hoover here in the corner. He's the National Soil Survey Center Director from Lincoln. I'm located in Salt Lake City. And as the title suggests, I'm going to talk to you about SCAN today, a little bit about the history, current condition, and some exciting new information about where we're moving in the near future and changes we made already. So let's go ahead and get started. Okay, before I dive into SCAN itself, it's really helpful, especially for a group that has kind of a Midwestern and Eastern bias. It's really helpful to talk about SNOTEL because they share a lot of history, I guess. So the SNOTEL network is a network of high elevation autonomous solar powered weather stations that also measure snowpack. And we try to characterize and measure SWE, which is snow water equivalent. It's the bread and butter, most important data element for water supply forecasting. So these SNOTEL sites exist only in the western states, so west of Colorado, essentially, and they're installed in high elevation areas that are mountainous, in areas that accumulate a lot of snow. So SCAN, on the other hand, SCAN fits kind of a niche in the NRCS portfolio, I guess, of NRCS things between SNOTEL high up in the mountains and our conservation activities down low in the ag and rangelands. And so that's kind of SCAN's programmatic ecosystem, I guess. It was designed and conceived to help improve irrigation efficiency and assess and improve and understand rangeland productivity. The sites are typically low to mid elevation, elevation dependent on the location, of course, whether it's in the west or the east. They're installed primarily on spatially representative soils, where we try to, and they exist or sited on or kind of immediately adjacent to actively managed and working agricultural and rangelands. So these may even be lands that our customers, our producers own. And that's intentional. It's part of the need. So climate SCAN started in 1991 as an offshoot of a pilot study with 25 sites throughout the country. At that time in 1991, the SCAN program borrowed very heavily from the SNOTEL program, sharing a lot of the components and a lot of the look and feel. In fact, the first 25 SCAN sites had a wooden shelter that we have at SNOTEL sites. It looks like an outhouse, but it houses the electronics. Most notably, though, we borrowed the meteor burst technology, which allowed these to be standalone sites like SNOTEL sites were. In a lot of ways, SCAN was ahead of its time in 1991. There was a lot of interest in it. It was amazing. It was a neat collaboration between the SNOTEL people, or the snow surveyor folks, and the soil folks. And it was very successful, a lot of interest in it. And it grew organically as such since then. And we're now up to about 209 sites. We'll go over that in a minute. But unfortunately, the staffing support and resources didn't keep pace with the size of the network. And the network has suffered as a result. Todd showed that earlier today. So what is a SCAN site? You've already seen a picture, actually. It's pretty straightforward in terms of the array of above ground sensors, all the stuff you need to calculate ET. And we also obviously install an array of soil moisture and temperature sensors at fixed depths across the network. So like any other weather station, you can generate a graph of time series graph of the cumulative precip during the growing season. But what sets SCAN apart, or at least did initially, is that when the sites were installed, we did a full soil characterization. So we had a soil description, and we grabbed samples from the site for characterization and analysis. So what this does is it provides crucial context. We're not measuring a column of air, we're measuring soil. It's really, really important to know what you're measuring. It helps with the data editing. It helps knowing if the sensor is down or not. And it certainly helps in converting that data, like the volumetric water content, into useful information. So for instance, we return to our time series of accumulated precip over the growing season, and you can see the spikes in precipitation. So the water, rain hitting the tipping bucket. You can see the wetting front hitting that 2-inch sensor. You can see it moving down through the profile. But with the context provided by that soil data, you know that this is roughly the zone of plant available water. You know that it's getting to the point where there's too much water. We don't think there's such a thing in Utah really, but I guess it's true. And then you get to the point where you have no storage, and now you've got a different problem, you know, the potential for flooding. Okay, products. I'm going to talk quickly about a few products. This one is one that's being generated, but more broadly, products stemming from scan data have suffered the same. Too much. Sorry.
Just trying to get rid of this.
Oh, yeah, those have been coming up.
I can knock it out on my side.
Okay. So product development from scan data has lagged, as has, you know, kind of everything with the network. And of course, if you've got sites down, you're not going to use critical and scarce resources to develop some neat new tool or so forth. So anyway, pretty limited, but in Utah, we have 34 scan sites, and part of my last 10 years has been maintaining and editing, QA/QCing those data. So we have a pretty good data set, 15 to 17 year POR on those sites. And we've taken advantage of that in doing so. The Snow Survey Office, rather, in Salt Lake, where I've worked, for the past decade, has developed a monthly product called the Climate and Water Report. It doesn't replace, but it supplements the spring months bread and butter kind of report called the Water Supply Water Supply Forecast Report. That's published by all snow offices, but only in the months of kind of March through June, depending on the runoff season. So we generate entire different and additional product of basinized low and high elevation data that we provide primarily to the state of Utah folks, but drought monitor and so forth. Locked up.
This just has to be in this little window.
Oh, sorry. Okay. As I mentioned, the product development it's been super limited, but the little bit of time I've had to develop stuff has yielded some really interesting results. This is just a quick summary sheet of one site, the Sand Hollow scan site. It's in the warmest corner of Utah in a thermic soil temperature regime. It's our corner of thermic. That doesn't mean anything really, but something to say. Maybe to Dave it means something. But I put this together, this little fact sheet for the Washington County Water Conservancy District. They own the ground that the Sand Hollow scan site sits on. But when you've got a clean data set, there's some really neat stuff that pops out. And some of it's counterintuitive. I field a lot of questions in my current and past positions about soil data. And one thing that's interesting is that this site reaches almost 150 degrees on the surface regularly. So keep those flip-flops on when you're visiting Sand Hollow. Again, when you have a nice clean data set, you can do all sorts of interesting analysis in terms of the magnitude and timing of annual precip. This was to help in some ecological site description development, and also useful in soil surveys. And of course, the entire scan network contributes data to the drought monitor effort, and I individually participate with the state of Utah folks on moving and adjusting the drought lines in Utah. Okay, where to get data? So it's not all bad. There are lots of good sites running out there, and all the data is free. We're not like a Mesonet. It's all on the web. Well, most of the data goes out through automated products, but to get data on the web, it's fairly easy. I'm going to run through 4 sources. If you're interested in any of these, getting the hyperlink, just see me after and I'll send it to you. I didn't want to put it up on the screen. It's too hard to write down anyway. So the first place to look is the National Water Climate Center interactive map. This is a map environment, which I prefer. It's got both the scan and the snowtail data on it, and it allows you to pull down both charts and tabular data. Additionally, each scan site has its own website, and that's another place you can see a picture of the site. It's the link to the lab data is there, and you can collect and get charts and tabular data there as well. Discussed earlier was the conservation decision support tools that Cornell has developed. We contracted Cornell to serve these up. They've developed them, aggregated a bunch of tools that they've developed for, different entities and have them all on one site. Really an amazing website, pretty dynamic, pretty interactive, and really, really good at turning that data into information. I think we're always data rich and information poor. This website's great. We've renewed for next year. We're going to continue with that. And lastly, for purely tabular data, we have a report generator that will allow you to drill down to very specific data elements. Okay, current state of the network. We're at about 209 sites. We've actually decommissioned a few. One you'll see here in a minute, and you'll know why. So we have sites spread throughout the country. Not all states have a scan site, but most do. We also have sites in Alaska, Puerto Rico, Virgin Islands, and so forth. And we have 22 T-scan sites. I'm not going to talk much about the T-scan effort, but essentially it was a scan light weather station type site oriented more towards STEM education. And these are sites that NRCS installed on tribal areas, hence the T. So the current state of staffing is still a little rough. The important thing to note here is that there's the three at the bottom are the three folks dedicated entirely to scan maintenance and support. And we only have 7/10 of Alex on the corner there, so 2.7 people. The good news is that as a percentage, before they hired me, it increased in a big way when I was hired. Okay, more bad news. This is unfortunately, this is definitely the worst case scenario in terms of site maintenance. There are above ground sensors hidden in the tree there. Obviously, the site was still reporting, but the data quality was a little bit suspect. This site's been discontinued, and we're going to move it. And this is what happens when the agency eats its dessert first. It goes for the sugar high and doesn't do the work of providing that steady funding for the O&M. That's the operations and maintenance is the killer. It's not the sexy part, but it's so important. And that's kind of what's happened for decades. But there's light at the end of the pyranometer because we are implementing, not at this site, but we're implementing a bunch of changes, and we have a proposal put together. So I'm going to talk about those quickly in the next couple of minutes. Okay, great. All right now, this says future direction, but these are changes we're making already. We've gone from scan being managed only by the National Water and Climate Center in Portland to a co-management model where most of the management's occurring by the Soil and Plant Science Division, so the soil survey folks of NRCS. We are looking to have permanent staffing in 3 regions throughout the country. As you can imagine, travel costs are a killer, absolute killer in a national level network. And to further ameliorate those issues, we are going to draw from existing soil survey field staff throughout the country and employ them in the maintenance, troubleshooting, and quality assurance work for scan sites. We're going to do that through extensive training because it's easy to underestimate the damage that somebody who's well-intentioned but poorly trained can do. So extensive training, and we are purchasing and will fully outfit 12 cargo trailers with all the tools necessary to knock down the brush, do the vegetation management, calibrate the tipping bucket, et cetera, et cetera. In addition to the things on the slide, there are a bunch of things behind the scenes that we're doing in terms of syncing up calibration set schedules. We're hardening the sites with brand new stainless steel NEMA boxes that won't rust and are much more watertight and so forth. We're evaluating new sensors because there are known issues with the Stevens in certain kaolinitic high clay environments and salty environments, which we have close to Salt Lake City. So anyway, a lot going on in the background. These things are happening, and there is a proposal in the works to expand the site to 1,200 sites nationwide. So another 1,000 sites. This will be a heavy lift, but we'll have infrastructure in place, hopefully, to make that happen. It'll cost, we expect, about $8 million. And if you like SCAN or would like to see it get better, you can write to Dave Hoover in the corner. Dave will aggregate that support and push it forward. And this is just a quick look at a rough a future hopeful staffing structure. But that's all I had. So are there any questions?
Question online,
Okay.
is your real-time scan data quality controlled, or is it average for weeks or months? What are the steps in the process?
Yeah, I started to think about putting that in, and it just got too complicated. Right now, we have a statistical analyst, so not somebody with a science background, looking at the data on a monthly time step. And unfortunately, that is basically to look for dead sensors. And part of the huge change we're creating here is to put science folks in charge of QA/QC, because she's great, but it's a ton of information and data, and she doesn't have the natural science background. So we hope to have a cadre of folks who can work with me and Jordan Clayton and other folks within this group, and we'll be able to tease out whether it's the sensor's frozen or not, so on, issues like that.
In the past, when I've done digital data acquisition, scan sites, it was challenging to try to put the disparate sensors together into a cohesive data set. For example, there'd be observations at different depths of different sensors, and then you'd have to parse together, some sites had different numbers of columns of data, so made the scripting or coding challenging. So is there a more standardized way to present your data archives so that it makes it easier for researchers to use the data?
That's a good question. So were there timestamps missing?
Sorry, you might repeat that 1 year.
Oh, yeah. Well, that's a big one.
Yeah.
So you've had issues with?
I think it's a challenge to parse together the different sensors that had different measurements, different measurement depths and such, and therefore you had you were parsing together data sets that had different columns and labels and such. So trying to piece together the different sensor data to make it easier is what I'm trying to get at.
Okay, so the question is about ease of use, essentially. We certainly don't want that to be the situation. I'm not sure what mechanism you're using to pull the data down, but I'm happy to work with you if there are issues. It depends. We feed a bunch of different ways, so I'm not sure which mechanism you're talking about specifically.
Maybe, can I rephrase in a second?
Yeah,
sure.
Maybe if someone were to do a regional or CONUS scale analysis that they want to use SCAN, how would you recommend downloading data from that many stations all in one? I don't want to have to click download 200 times. How can I?
Okay. Yeah. So clearly that would be the tool to use would be the report generator, which is the last of the options I put up there. happy to send that out in a link. So that allows you to pull a selected set of whatever combination of sensors, even across network, different sensors, sites, excuse me, across network, different sensors at different depths, and so forth. And you can, of course, define the time frame and the time step both. It also builds in the functionality to do averaging and so forth.
Does that spit out a CSV file?
Yes. Mhm. Yeah.
I'll say it's the HTML code. I basically automated a script that queries everything you just said into one line. You can just script that.
It's just parsed.
And it parses out. You just run it against every station. It takes a while.
Mhm.
I get it every station. I can get every station every day.
Okay.
If I want to. Yeah.
It's a week. I think, maybe it's just in the last 2 years or so, but it's been really.
It works pretty well.
Good.
It's way better than the old way.
That's a surprise.
When it was carriage return.
Yeah, 1 year at a time, I think.
Yeah, that's the old, yeah, we're moving away from the website, each site's website, that those queries go to a different server essentially. And I don't know what the time frame, I don't know when they're sunsetting that exactly, so I shouldn't say anything, but we're moving to the the server that serves up the interactive map queries. Yes, sir.
Plans on incorporating webcams so that you know when the sensors are damaged or whatnot.
That's a great idea. Not at this point. We do have a lot of, so we're making progress, but there are, I guess, higher priorities. Like I want to move all the tipping buckets off the tower. They shouldn't have been there in the first place. We're going to put alter shields on all the gauges, so forth. But that's a great idea. I think that we do start to run into data issues over the cell modem. I think maybe that's not a problem, but we're still a little underpowered. Our battery age, mean battery age, is quite old. Some of them in the 17 to 20 year range. So the ship is we're still bailing. When we get the ship bailed out, we definitely want to do, yeah, because there's so many uses for a camera at the site, and especially when we're 3,000 miles away. Yes.
Just want to say that wasn't my idea pretty earlier. And then another question, can you elaborate a bit on what caused that issue where the tree managed to grow big enough to obscure the sensors that much? Was it too many sensors to maintain? Was it access issue?
Yeah, so the landowner loves the scan site, but doesn't visit the property. He leases a house that's close to the scan site to a renter who hates looking at the scan site and planted the tree there. And our contractor, who we don't use anymore, had maintained the site. But to make things worse, the renter was watering the tree. So it actually sprouted up quite quickly. It's the perfect storm of terrible.
Yeah.
It's tough to air your dirty laundry. Sure.
So you talked about the three positions, looks like. Are those two, you're the one, and then there's gonna be two more regional positions?
I believe so.
Okay, that's the plan. Is that rolled in the $8 million plan, or is it actually on a separate track?
I think we're trying to move that forward independently of the 1,200, because the issue is that we've provided proposals. Mike and Dave Mike Strobel, I mean, have been proposing this or a variation on this for years, but we really either need to completely expand the network or maintain what we have adequate. And that needs to be the either or, not we need to expand or nothing. And hopefully we can do one or the other. So that, I think, would be part of the model, to fully and completely support the existing network and infrastructure and the T-scan program as well.
I'm gonna ask the last question here.
Sure.
1,000 more stations. What are the decisions to get where those 1,000 stations go? Because coming from the Midwest, I see some disproportionate distributions around the country. Beth could probably nod her head. None in Indiana. Yeah, how does that decision get made about where those? Is it pretty systematic or?
That's a great question. That's an evolving process, where to site and so forth. And we do have holes. NRCS works with our state conservationists. We have to work with our state conservationists carefully. So there'll be some give and take with them, but we are hoping to drive. Feel free to jump in, Dave, if you have a better answer. We're hoping to essentially allow the need to drive the siting. And so it hasn't happened in the past, as evidenced by the map, right? It's been initiatives and so forth that have driven this organic growth. And those initiatives certainly paid for, the installation and the press release and the ribbon cutting and all the pats on the back, but then the initiatives don't pay for the ongoing O&M.
What we don't want to do is make it a geopolitical decision.
Right.
So we don't want to do one per county or 20 per state. We want to look at representative soils, representative land uses, climate variation, and landform variation.
Yeah. So we need to email you weekly once you guys get the money.
Well, I was gonna say, if we write a letter, how many stations does it get?
My letter's written.
Send it a self-addressed on a $20 bill.
Yeah. All right, well, thank you very much.
Sure, thanks.
Okay,
Last,
right. Well, Marina's gonna lead us home here.
least in some ways.
Hold on, let me get. There it is.
And
Okay.
then, is there any trickiness between using
I
this and?
I would use. Okay.
Because probably nobody's going to be joining at this point. Right, wasn't that a bit of a problem? Yeah, okay. All right, everybody, thank you so much for your patience and continued partial or however full attention that you can give for this very last presentation of the conference. I was thinking in my head, last but not least, that's not something that I should be saying, but I want to say two versions, last but not least, because I'm going to be giving a programmatic presentation. So we really are getting away from the science, although I'm going to dabble in it. And if I make mistakes, you're going to correct me. But also last but least, in the true sense of you guys are the power. You guys are the ones that are making the difference. And then my role, as I see it, is just to, do my part to help you do that. So, so least and not least at the same time. Okay. I'm Marina Skumanich. I think you all know that. Again, work for NIDIS as program specialist, whatever that means, but with a specific assignment to provide this coordination for the National Coordinated Soil Moisture Monitoring Network. I have a few other assignments, but that's the main one by far. And so I'm going to talk about challenges and opportunities. Probably most of you have seen this like multiple times. This is our go-to starting slide. The National Coordinated Soil Moisture Monitoring Network, that's the title we got from Congress. NCS MMN, what are we about? Again, I think this is kind of percolated up through these last 2 days, but it's about developing a system for coordinated, high quality, nationwide soil moisture information to serve the public good. So that's what we're all about. And the three main areas we do it. One, we want to build this network of networks, this meta work. I had an idea for a name, meta, not a metaverse, but meta net or some meta net. It's going to be a meta net. Okay. So, dealing with these technical and logistic and contractual problems to pull that data together from all the different mesonettes. And then also pulling, of course, satellite and model data as it fits. And then we want to build, as we have been, as you all have been, a network of people, this community that reinforces and drives the technical activity, the research activity, and then finally the delivery of services to the public. And then this third thing, sometimes it's on the slide, sometimes it's not, but I think it's important, is that in order to really realize this vision, we've got to get that R&D, which again, that's where you guys are helping us, getting their R&D to deliver these real-time, user-friendly gridded maps and other tools. So that's what we're all about. The bottom there is just a sense of the different organizations involved, and a little bit more involved at the executive committee level, which I'm going to talk about because I'm going to go quickly through this slide, which is the history slide, which I think has been in talks for, I don't know, at least 4 or 5 years now. And I was going to drop it out, and I thought, no, this is the group to really show this slide, because you know that this national multi-agency effort didn't start just a couple of years ago. It certainly way preceded me, but it started way back in 2010, or maybe even before. Some of you were thinking about it, but 2010 is when Mike Koch says we mark it as he and Tyson got together and said, we're going to do this moist. We're going to get this moist test bed. We're going to work together and start building, sharing that information and going from there. And then there were every year another workshop, which is primarily focused on the research, but then also occasionally with these workshops, there was some time spent on this programmatic development. What's the concept here? What are our main targets? And it really is interesting to look at some of the reports and other outputs from that those years, because you can just see the stepwise progress in thinking, in collecting what are the issues, what can we tackle, and the decision we're going to look on this thing, and then, you know, voila. I mean, it's wonderful. 2018 things got a big boost. 2 streams. I mean, the second one I got listed, congressional direction. We got NIDIS reauthorization, a requirement to work with our partners, develop a strategy for this national coordinated soil moisture monitoring network. So that's kind of a formal statement that we're doing, you know, we as a country are doing something. But you guys had already organized your executive committee before then. So you kind of knew, and then maybe you influenced as well you should on that congressional direction. So that was a big push. And with that, hard work was done on this strategy. It's about 80 pages. I don't think that's particularly long, but there's some really good information, both on state of the science, why it's important, and then some of our ideas about what we need to do about it. So this is a current executive committee. Some of these names, I think most of these names you'll recognize. And the light tan color there are the people that were able to come to this meeting. A couple of the other people, several of the other people were interested, but just couldn't fit it in. So again, this executive committee and this broader community here, kind of all the same, we're all the same people. And if any of you want to be on an executive committee, you are welcome to come join us. And I'm not going to go through all the recommendations of the strategy document, but here, you know, voila, we did get that strategy document kind of finalized or written and submitted for review in 2020 and then finalized in 2021. And we're working on the things you'd expect: more data, quality standards for that data, research to develop the methodology to do this interpolation and other things. An emphasis on communication and outreach. You know, again, this is about a community building and the value of that two-way communication to really deliver on meeting societal needs. And then that last bullet, sort of our holy grail, is this real-time, high-resolution gridded national maps and user-friendly products. And I've got my little 3-legged stool there. I decided I put the stool instead of the words. We've talked a lot about in situ at this meeting, and there's really good reasons for that. But we also know that the satellite data, Jonathan, Andres, if you're still here, and the model data, Jonathan, are also key components. And working together, we can capitalize on each data stream's strength and come up with better products. Okay, really quickly on some of our accomplishments, and this is sort of like of the last few years' accomplishments, although again, accomplishments started a decade ago or more. We have the strategy document. Okay, that's just sort of a programmatic step, but you'd be surprised how valuable that is when we're talking to people in Congress or otherwise. You know, there's a kind of a there when you get it on paper and get some steps written down. We've had some really important in-situ network expansions started. Again, we talked about the Upper Missouri River Basin yesterday. That's really going to be transformative, those 540 high quality stations. But also then this morning we heard about the Alabama, Georgia, and Florida build out. And just like, for example, on the map of Florida where all the stars were, like in the Florida Fawn network, there's no soil moisture sensors there, or maybe one or two of them. So that's going to be another big push in another region of the country. That'll be really great. We've had product advancement. Some of it has been specifically because the NCS-MMN Executive Committee figured out this is important. Let's get some resources here. And some of it is just because you guys want to explore things and do things, and you build your own models. And we've got NASA Sport List, which is really getting a lot of attention, doing a lot of great stuff. I'm going to come back to you. And Crop Chasma came out of NASA and USDA. Some products that are coming out that are really serving people's needs. The first one on the list, nationalsoilmoisture.com, that is one of our pilot prototype proof of concept. Can we bring some of this data together, even within the constraints of the current contract limitations and sometimes data gaps for more reasons than one? Can we bring it together? Can we interpolate? Can we get some graphical and other tools available, in this case now historical data set, that can serve users all along the stream, because we want to make sure we are helping the researchers as much as we're helping the farmers or the water supply managers, because those researchers end up helping too. So really exciting product advancement. And then that last bullet, ramped up outreach and engagement. Mike and I were talking about it. It's like last year we were tired because we had, a symposium after wildfire symposium, and then we had the soil moisture operators workshop. Then we did some listening sessions. Then we had the workshop. It was like, okay, this year we're going to take it a little slower, but those are all about getting out to the different sub-communities within our community and serving their needs. And so we're going to carry that forward. And we heard from you, and I think, very loudly, we understand the value of another soil moisture network operators workshop, coupling it, I think, maybe to this question about quality control. So, a good opportunity going forward there. In addition to workshops, we've been doing a number of webinars, and I have to say, NIDIS does a lot of national webinars on, drought focused, of course, and there's some big drought issues like southwestern drought, right? Or is it aridification? That's another question. But the Soil Moisture 101 that Mike and a few of you helped with, Jonathan helped, it was our highest attendance. We had 1,300 people register, 750 show up. I mean, that was really exciting indication of the interest. And that was specifically targeted at Weather Service, National Weather Service, and other operational climate service providers, so that they could think about how they might be able to apply this as they're giving advice to their communities and end user communities. So it's really a lot of good stuff going on. But we want to do more. We want to do more. And I was looking or maybe I just heard it on a podcast or something. The discussion about the word priority means the thing before. But somehow in our culture, we've now got multiple priorities. So we got here, you can see 6 priorities. It's a little bit much in terms of super focus, but on the other hand, we know that we can make progress along each of these a little bit, and even that will be really valuable. So data generation, one or two categories here. We want to increase monitoring in underserved areas. I mean, that's pretty much the standard approach, but the two that we have called out are forests, which you've seen reflected in some of the reports, research you've heard reported today or this week, and then tribal lands, which is going to be a little bit of a stretch for more reasons than one. This is something we've worked on with the scan folks, but it's on our list, and we're going to keep trying on that. Deliver technical assistance to in-situ networks. This installation protocol that Todd talked about, that is an NCS-MMN product that we think, we know is going to help. And we've got an idea of today, again, this data quality, next component of that, which should be a series of protocols that provide consensus, expert opinion on how to do these things as best we can. Coordinate sensor testbed activities. Again, we had some reporting on that, a couple different presentations. Southeast Alabama, and then Andres Patronani's presentations. Taking advantage of the fact that there are these different test bed activities with their own kind of focus and priorities, but how can we share information or even do more so that we can amplify the value? In terms of data delivery and application, this first one, develop a curated soil moisture product kiosk. So we talk a lot about these new products that we want to do, gridded, real time, blah, 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 high resolution. But we know that there are products out there already. There were products out there 5, 8, whatever years ago, and some of them are very valuable. And as someone pointed out, you don't always have to be accurate to be useful, right? So, but what we've been thinking about is how can we curate a little bit the existing products just to help, again, the user community, because your average, climatologist even may know that they want to know something about soil moisture, that it might make a difference in their involvement with the USDM, US Drought Monitor authors, but they're not experts in soil moisture like you guys are. So do they know where to start or what the issues are, what the uncertainty problems are? So if we can curate some of those products, that will be a real service. And we're starting by at least getting them sort of systematically documented. And then the hope is that we can actually do some research and get some papers that do some little bit more consistent comparison work. We want to address the soil moisture and wildfire nexus. Again, some of these presentations you've seen are reflecting our recognition of how important that is and how we can utilize and harness soil moisture to make a difference in that field. And then initiating this data value study that I mentioned. Okay, so those are some of the priorities. I got a couple more slides. So some key challenges, and this is not like a survey key challenge. These are those just things that just popped into my head that I feel like they're what bothers me when I'm thinking about making progress here. So, and I'd love to hear from you all other thoughts, but okay, resources is obvious. I mean, NIDIS has been in the position where we've had some money to direct in this direction, and we've got our executive director really gets the value. She's on the executive committee. And so we've been able to help in that regard, but more is needed. And certainly if you're talking about O&M for, we need $8 million a year, we're going to need resources, especially for the ongoing in-situ monitoring. And how we can do that, that's what we got to focus on. A functional data platform. We've had this conversation already today. We've got to get something that works better than MADIS, or MADIS. We've got to get MADIS fixed. We need, it's not, I don't think so much of a technical, it's not really a technical problem, right? And this, we're not, you guys correct me, but I don't think we're talking about huge amounts of data, like super complicated issues. We just have to get through some organizational logistics and get the pedal to the metal to do it. So, and the Upper Missouri River Basin may help us do that, thankfully. Congress telling us to do it. Some of the research issues, we've made a lot of progress on this. I know Quiring and Ford have done some really good stuff on interpolation, others of you as well. But it seems to me we could do more. There could be more ideas, better ideas. We've had a little bit of that conversation already today. Spatial temporal depth, how do we handle, the complexity of soil moisture information to make it meaningful? Period of record, I italicize that because that's something that we really think about a lot at NIDIS, because we're so much in the climatology space, and we know we have to understand those extremes and how often they occur, et cetera. But we still need that data. These new stations, and even the relatively new stations, there may be information we can extract. And it just seems to me that there are going to be different kinds of good ideas about how to do that. We can use our ingenuity to get around that problem. And then data quality assessment and uncertainty. And that was one of the questions I was going to ask you, Steve. And if it actually comes out a little bit more on my next set there. But how do we communicate uncertainty to our users? I mean, how do we use the data that may not be super high quality, but still has information, and how to make sure people understand where that information horizon falls. So more research there. Again, on the user needs side, first of all, just my first bullet, how do we address that wide range of users? During our listening sessions last year, I don't know, I naively thought we were going to come out with we need to target like this sort of temporal space, time, time series, it's gotta be real time or whatever. People really don't care that much about historic. I thought we'd kind of bound our range of options from time and space, et cetera, resolution, and we didn't. I mean, what we saw was, enough people want all the different values of any particular parameter. So that's great. And then we want to address that, but how do we do it effectively? And sort of timing, et cetera. And then again, how to communicate uncertainty. How can we, and I actually think, I mean, I'm not as knowledgeable about all the other areas of science, but I actually think this domain, we can make a difference in how people understand uncertainty. I don't feel, okay, I'm sorry, there are atmospheric scientists here, but I don't feel like you guys do a good enough job out of it, because I think people still get confused about what, probability means or something. So I don't know, feel like there's some active questions there. And key challenges is sort of like challenges and opportunities go together. So there are a lot of opportunities here. My last slide says opportunities, but I was realizing it's really more about conditions for success. And again, these are elements that make me feel that success is here or coming. And these are just the things that sort of three top things that came to my head. I know there are more, but these are the ones I wanted to pull out. Infrastructure upgrades and build outs. Okay, we just heard about SCAN, and it's really music to my ears to know it's really wonderful to have that revitalization at SCAN, and fingers crossed and letters coming to help get that funding, because that's an important resource, long-standing workhorse. We got to keep using it. There's an opportunity, also a proposal in the Forest Service to build out their RAWS station, the remote automated weather stations with soil moisture. That'll be another game changer, right? Getting into that forested terrain, and a lot of research about that, right? How do we manage the complexities of that? A number of states have come to us saying they're interested in how do we go about getting a mesonet. And I'm sure you mesonet folks get this all the time too. And just, it's pretty exciting. And the notion that, yeah, we want to get this going in Idaho or Hawaii or whatever, that's, I can see some energy there. And then there's also, now some play by nonprofits, some of the bigger, more land-based nonprofits or land-oriented, like the IRON network that someone was mentioning, but that's Aspen Global Change Institute. They care about what's happening to the land, and they have the capacity to get those $8 million or whatever, a little bit less in their case. I don't think they have that many stations in mind, but they and the Nature Conservancy, et cetera. I think there are going to be some new areas where people are getting some data streams. And then of course, there are also the research ones, which may be of term duration, but maybe we still have data there that we want to extract. Okay, that's the infrastructure upgrade build outs, continued public and congressional engagement. This is another place where we're seeing between the UMRB project, and then I was mentioning this Water Data Act. Congress sees soil moisture, and I don't know enough about that relationship to know how much is it the producers, et cetera, and the water guys talking to their congressmen, or how it works, but we're seeing some good energy in terms of keeping the funding, getting the funding going. So that's really exciting. And then really in this case, definitely last but not least, again, condition for success is the research that you guys do, the care you bring, the joy you bring. I'm sorry, you guys want to talk about this for hours, and that is exciting, because that's what's going to make the difference as we take all these individual ideas and bring them into something that's coordinated, high quality, nationwide, and serving the public good. Okay, that's it for me. Questions, comments? Yeah, that's such a questioning kind of presentation. Yeah, I mean, maybe we're ready for, should I, online? Yeah. Is anybody online anymore?
We've averaged about 25.
Okay.
There's, I'd say 23 people.
Well, thank you, online people. I hope you're not asleep there behind your computers. So anyway.
Two announcements. I certainly don't want to steal questions from Marina. One is that at the Byrd Center, they really like to recycle these plastic things so that they can use them at future conferences. There's a little basket out there, so you're welcome to take your name tag home and if you want Marina to sign it or anything, or Mike says he's the award winner to sign it, great, but just leave the plastic part here so that they can use it again. If you brought a poster and you want to take it home, please take it down, otherwise they will recycle it tonight. So, and other than that, thanks for your attendance, safe travels. There will be absolutely a future workshop. We always talk about where we hope it's going to be next year. I personally hope it's that Mike is hosting. I think Mike hopes that he's hosting. So we'll just, I don't know, maybe you need letters as well. I don't know.
Yeah, so I did get a note yesterday that they are opening up the National Ag Library in Bethel, Maryland for meetings again. So the hope would be next year. We already have discussions starting to have it hosted there as part of our traveling circus, shall we say. And then we'll have, so we have in Maryland, which puts us kind of in the sweet spot of getting a lot of DC folks coming in. $8 million. That's nothing. They don't start talking until 5 million. So that's one way for us to get into the spotlight there. And then we move on to other sites around the country, hopefully Illinois, Texas, things like that. Want to pick your favorite state? Let's try and go there. Or a state that's just putting out new stations.
Hawaii.
But that's our goal.
Hawaii.
Mesonet.
So I'm in Idaho. I didn't go there. Hawaii. So there's a definite hope. We're looking at dates and logistics of that trip. So you'll find out soon enough. A placeholder, hopefully, so you can not schedule your family vacation. And extra special thank you before any other questions for Marina. Hosting this is not an easy job, not doing it. But this has been a fantastic workshop, if you haven't noticed. Kind of flawless, with lots of support from students and great exposure for the work done here at Ohio State University. And just thanks again to Stephen for making this all happen on such short notice.
So yeah, any questions for me, or comments? How about some closing comments? This is when we need the Manometer poll. Like, what was the thing you what enjoyed the most about the conference? You know, the lunches, happy hour.
I like the Ohio guys. I thought they gave some great talks. That I didn't know anything about, especially
Yeah, that was Eric Wilson recommending Scott Shear as a speaker, and that was super interesting. It was great recommendation. Claudia Cotton and having her come in. So just kind of a best practice for future hosts. I think it was a good opportunity for me to meet and hear from some people who are on. It's a big campus. I don't know everyone. I've never met some of the people who presented, but it is good for us to invite people and think about continuing to grow the community strategically in those ways.
So as with lots of conferences, it would be nice to have the presentations posted so we can refer back to some of them, steal slides as we need to. So is there a plan to accomplish that?
So we'll be, for the folks online as well, I'll send an email. We have all the presentations, but we won't post them without permission. So I have to get permission from every presenter. We also have a Zoom recording of every presentation. I get their permission as well. I have removed a presentation or two in the past if it's unpublished work, but I'll go in and edit the videos. We post them online to YouTube. We'll put them, they're freely available. You can see at least the last 2 years of presentations through NIDIS. You can find the links there. I'll certainly go back and rewatch some of these, especially Claudia's and Scott's today, because they were just so fascinating. Plus, you can do it a little bit faster, 1.25 speed. Save some time, efficiency. We all like that. But yeah, we'll try and get the presentations available, but at least the YouTube videos, if there's no redactions, will be, and they'll be a little bit cleaner. They're not just going to be 8 hours of find your speaker. I chop them up in kind of chapters. So, Nathan. We had an attendee list. I thought it was sent out. I had to update it a little bit. A couple people added. Yeah. So yeah.
It was in the email with the agenda.
Yeah, it was in the email of the agenda. I had maybe 8 people add after that. But that's a good resource because people have questions for folks, and I tried to put some emails in the chat as well, but we're still learning, and folks online, sorry if learning how to do the hybrid. I thought this worked very well. We'll be adapting. I tried to get a second camera going for a little while to see how that worked. I didn't want to burden the system. And next year we'll have a pretty good system, hopefully at Beltsville. I'm thinking now about how to have other engagements there. So hybrid's gonna have to stick around for a while, at least, though we'd like to see everybody in person, sipping coffee and chewing on some snacks. So, but we'll certainly keep this effort going to keep hybrid and engagement throughout the year, not just once a year. So what, let's see, Peter. Right in the middle of it, just sitting there. What was your favorite part of the meeting that's not a presentation?
My favorite part of the meeting that's not a presentation?
Yes.
I really liked some of the conversations I had at the bar last night.
At the bar last night.
Yeah.
Good. I didn't get any photos. I think that I could have charged some money for not taking, if I took a couple photos. But yes, offline conversations are a highlight for me as well. Ronnie.
Posters.
Posters. Good poster. We had a good hour long. I was pleaded with to not have a 2-hour-long poster session, and I think that 1 hour was a sweet spot. It was good. Who else? Nathan. Lunch. You liked lunch? You like not having to walk outside?
Like, I thought the questions were really good. You know, when Ty was doing his presentation, great question about our percentiles always needed. I mean, that was like, I mean, stuff like that, it just made me step back and evaluate some things. So there were some really good questions.
Beth, what was your favorite part?
I enjoyed the happy hour as well. I felt like it gave me a chance to talk to people that maybe I wouldn't think to the great.
I will stop. Some people are hiding their heads, so I'll stop right there. But yeah, go ahead.
Yeah, so AGU is in Chicago this year. I think some of us probably here. The thing about AGU is it's so massive that for me, I interact with climate folks mainly, and that's kind of it, because I burned out by that time. One of the things I love about this is they get so many diverse perspectives from people who aren't working specifically in the field, but are working on a problem that. So when I talk to people at this meeting, every single time I come, it's like I've never thought about soil moisture in that specific way, because I'm looking at it in the way that I look at it from a standpoint. So every year I come with something new from here to do with that.
Okay.
Adding on to the poster session, really good group of students this year. Hope so will come back to other meetings.
If you're a student, raise your hand. Student, graduate student, postdoc. Back row, what was your favorite part? So these are folks that you'll be seeing in the future, hopefully for the rest of your career. Maybe some of us a little shorter, retirement's coming. But yeah, this is part of the community, and I did not have this type of experience when I was even just a postdoc maybe, but as a student, I did not have this experience, and just seeing how other folks think outside of your institution is very, very useful. So, all right. Any other last words, sir?
Give everyone a chuckle. I appreciated my no payment parking citation I received yesterday for not orienting my car correctly because the license plate was facing in rather than outside. That's $0, so I'm not gonna worry about it.
Oh, yeah. So speaking of automation, they have this new system, which didn't even cross my mind. So there's a computer plates. And then they link it to the database, either the people with parking passes or the people who have paid. And it's based on your license plate. So if they can't see it, and they recently, they sent out some note to everyone like, oh, we're gonna, but thankfully, I guess they didn't ticket you for real money.
This is where autonomy gets us.
Yeah, yeah. Anyways, it connects with the AI talk this morning.
Yeah. All right, well, I'll release you to your wilds. Thank you for coming, and hopefully we'll see you next year.